Welcome back to the Deep Dive. Usually, we take a pretty broad look at the world tech trends, history, maybe a bit of sociology, and we poke around for those little nuggets of curiosity.
Right.
But today we are shifting gears. We have a very specific mission.
We do.
We are looking at a stack of documents that represent a massive hurdle for a specific group of people. Student pilots preparing for their ATPL theory exams.
That's right. We are moving from casual curiosity to what I like to call high-yield study mode.
High-yield study mode. I like that.
Yeah, I mean, if you are listening to this, there is a very, very high probability you are staring down the barrel of a general navigation exam or perhaps instruments. And you have hit that brick wall known as aircraft magnetism.
It is the topic everyone loves to hate. And honestly, I get it. We live in a world of GPS, inertial reference systems, ring laser gyros.
Full of fancy stuff.
Exactly. We have satellites pinging us from space with atomic precision. And yet the regulators and the exams are absolutely obsessed with a tiny magnetized needle floating in a bowl of kerosene.
It does seem archaic, doesn't it? It feels like we're discussing navigation techniques from the 19th century or maybe even the age of sail.
It really does.
But here is the reality check, and this is why you need to care. The magnetic compass is the ultimate backup. When the electrics fail, when the screens go dark, when the alternator creates a surge that fries your fancy glass cockpit, that compass is still there.
It's still there.
It doesn't need power. It doesn't need a satellite signal. It's governed purely by the laws of physics.
It's the cockroach of the cockpit. It survives everything.
Exactly. And because it's the ultimate backup, you, the pilot, have to understand its errors perfectly. You have to know when it's lying to you.
That makes sense.
Because if you are down to the standby compass, you are already having a very bad day. You don't want to make it worse by misinterpreting the reading.
And the regulators know this, which is why they test it so heavily.
Yeah.
I've seen the question banks. They don't just ask which way is north.
Oh, no.
They ask about coefficients, latitude changes, field strength ratios. It gets intense.
It does. So, our goal for this deep dive is simple. We are going to take the source material, which, let's be honest, can be dry, mathematical, and dense.
Very dry.
And we are going to translate it into plain English. We are going to break down why the compass lies, how the aircraft itself messes with the magnetic field, and, crucially for the exam, how to calculate those errors.
So we're covering the definitions, the math, and I mean the mental math you actually need for the exam room, and the two big enemies, hard iron and soft iron.
The two big ones.
And specifically, we're going to do a deep dive into how latitude affects these errors, because I guarantee you will see a question about that.
That latitude piece is the widowmaker on the exam. It really is.
Wow.
If you don't understand the underlying physics of the Earth's field, you will get those questions wrong. But if you get the concept, it's free marks.
Exactly. And stick around until the very end, because we are going to do a rapid-fire summary, a cheat sheet, if you will, of the key takeaways you need to memorize.
The must-knows.
But let's start at the beginning. We need to define the problem. What exactly is deviation?
Okay, so it starts with a simple distinction. We have to separate the Earth from the airplane.
Right.
We have magnetic north, which is where the Earth wants the needle to point. The Earth generates a magnetic field, and ideally, your compass aligns with that.
Right. In a perfect world, that's the end of the story. You get in, it points north, you fly.
But then we have compass north. This is where the needle actually points. Deviation is simply the angular difference between the two. It's the error.
Okay, let's unpack that. If I were standing in a grassy field with a handheld compass, away from any fences or buried pipes, compass north and magnetic north are effectively aligned. Deviation is 0.
Precisely. Because in that field, the only magnetic force acting on the needle is the Earth. But as a pilot, you aren't standing in a field.
No.
You are sitting inside an aircraft. And an aircraft is basically a collection of metal, wires, engines, and electrical currents.
And I assume all that metal, it acts like a magnet.
It does. The source.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best